Hi everyone! In this video I'm going to show you how to convert quadratics in standard form to vertex form using a process called completing the square. Now first of all, why would we want to do this? The short version is standard form is kind of useless. Standard form. You can get your y-intercept from standard form really nicely, and standard form is what you need if you're going to be plugging it into quadratic formula. So those two are good purposes of standard form. But if you just want to graph a quadratic quickly, it's really handy to have it in vertex form, right? Like if I tell you that f of x is 2x minus 3 squared plus 5, we can just sort of very quickly sketch that. Because that's a positive a value, it's opening up, and the 2 means it's a little bit stretched. And this x minus 3 squared tells us that if we put 3 in for x, we'd get 0 squared. So we're going to have our vertex at 3, and it's going to go through the point 5 at that point, right? Because 0 times 0 squared would make this whole thing 0. So you're left with 5. So we've got a vertex at 3, 5, and it opens up, right? Like that's really nice, being able to sketch a quadratic really quickly like that. So vertex form, amazing. So I'm going to show you how to go from standard form to vertex form. But first of all, before we do that, we're going to need to do a quick review of some grade 10 factoring. So recall, if you have x minus 5 squared, remember that this is, this is going to be x squared. And then your first sort of FOIL or your first expansion or box method, whatever method you do, you're going to be multiplying x by negative 5 once, and then you're going to be multiplying negative 5 by x once, which means you're going to get negative 5x and another negative 5x, meaning your x coefficient will be negative 10. And then your integer piece at the end is going to be negative 5 times negative 5, which is plus 25. You can also do this backwards. If we have let's say x squared plus 16x plus 64. Well, I notice that 64 is 8 squared, and 16 is 2 times 8, right? And that's the exact same form we had here. This is negative 5. Well, this is negative 5 squared. And this is 2 times negative 5. And so anytime you've got that form where you've got a perfect square on the end and you've got double that, square root and an a value of 1, you can factor it in one step, x plus 8 squared. So the idea of completing the square is we're going to take some general quadratic that's not necessarily the right, integer part at the end, but we're going to force it into this sort of perfect square shape. That's the big idea of today. So let's go through and try an example. So let's convert from standard to vertex form. Let's start with a fairly straightforward one. F of x will be x squared minus 6x minus 5. If this was a perfect square, we'd want it to be x squared minus 6x, and negative 6 is 2 times negative 3, right? So we'd want our last thing to be negative 3 squared. We'd want our last thing to be plus 9. But you can't just, negative 5 isn't plus 9. So what we're going to do is we're going to cheat. We're going to keep our f of x equals x squared minus 6x. The negative 5 is just going to be chilling on the end over here. But what we're going to do is we are going to add this plus 9 thing right here. Now you'll notice, of course, that this equation is not equal to this equation because we've added 9 to it. And this is the really cool trick. This is the step, I should say. There aren't really any tricks in math. This is the step that allows us to do that. Just subtract it. Plus 9 minus 9 changes nothing. Plus 9 and minus 9 are inverses. And now in front, we have something that we can actually complete the square with. We can do this. F of x is, well, what's our perfect square here? This is x minus 3 squared. And then outside, what are we left with? Well, negative 9 and negative 5 makes negative 14. And if we wanted to sketch this now, like we got it in vertex form, that's awesome. We can sketch this really quickly. Positive 3 on our x-axis, negative 14 on our y-axis. There's our vertex. So there's our vertex. We've got an a value of 1. So this is going to be sort of our standard, our standard up opening parabola. Just like that. Oh, beautiful. Okay, this is pretty much as easy as it can come. We've got an a value of 1. We had a number, this negative 6. Half of the negative 6 was 3, right? And 3 is an integer. So we ended up getting an integer here. So that's about as easy as it can get. So let's try a slightly harder one. G of x equals negative 10x squared minus 80x plus 5. Now, this example has this negative 10 in front. So this isn't the special form perfect square trinomial that we'd really like. In particular, 10 isn't even a perfect square. So that makes it really tricky if you're going to try to complete the square with it. But it turns out we don't have to. What you can do is you can common factor out that a value. No matter what a value is here, you can factor it in front. And then what we're left with inside the brackets is x squared, because negative 10 reduces by negative 10, so there's no coefficient left, or an invisible 1 if you like. And negative 80 reduced by negative 10 gives you positive 8x. And then this plus 5 is just hanging out outside. Okay? That negative 5 is going to be outside those brackets until basically the last step. So this is our g of x. Okay, so g of x then is negative 10. Now, how do we complete the square with this 8x? What we need is we need half of 8, right? This thing in the middle is always going to be double of the thing you squared on the end. So half of 8 is 4. So we're going to have x squared plus 8x. And what we want is we want to add 4 squared. And if we add 4 squared, we also want to subtract 4 squared. And by adding and subtracting half of this number squared, what you're going to be left with is a perfect square here every time. So what we did here, this is the number we care about. So we took that number, we did half it, square it, add it, subtract it. So that's what we're going to do every time we're completing the square. We're going to take that number, we're going to half it, square it, add it, subtract it. Half it, square it, add it, subtract it. So let's go through. Now our g of x is negative 10 times. Our perfect square now is x plus, right, since this is positive, this is going to be positive, 4 squared. And this negative 4 squared is going to be negative 16, right? Now keep in mind this is minus 4 squared, not negative 4 squared. So sorry, that's minus 16. And then, the plus 5 is still just chilling on the end. Now we don't quite have it in vertex form because we've got this extra minus 16 inside the brackets. So what we're going to do is we are going to distribute our negative 10 across both of those things. So this is going to be negative 10 of our completed square, x plus 4 squared. And then negative times negative is positive. 10 times 16 is 160 plus 5. So last step, all we need to do is combine that 160 plus 5. So negative 10 x plus 4 squared plus 165. And there we have it. We've completed the square. And now a super quick sketch, just because why not? We're going to need some really tall axes on this one because we got this plus 165. So plus 165 means our y-intercept is going to be up here at 165. This plus 4 means our x-intercept is going to be at negative 4. So there is our vertex. Negative 10 means it's stretched down pretty steeply. So it's going to look something like this. All right, one more example. Now this example is a little bit different because we're going to factor out a negative 3 in this case from a number that negative 3 doesn't go into. And that's going to give us a fraction, and we're going to see how that affects our completing the square process. So our first step is the same as last time. This negative 3 in front we just really don't want to deal with. So we are going to common factor out a negative 3 from both of our x terms. So that leaves us with x squared. And now 5 reduced by a negative is minus. And then 5 reduced by 3 you can't, so it's just 5/3 x. So it's x squared minus 5/3 x plus 7. Now this negative 5/3, we're going to halve it, square it, add it, and subtract it. So h of x is negative 3 x squared minus 5/3 x. Okay, now what is half of 5/3? Half of 5/3 means you essentially need to add an extra 2 in your denominator because you're dividing by 2 as well. So this is going to be add 5 over 6, right? Because we need to have it. So half of thirds is sixths squared minus 5 over 6 squared plus 7 on the end. Okay, so what we've done here, right, the reason is that 5 over 3, right, divided by 2 is 5/6. So that is our half of the 5/3 that we squared, added, and subtracted. So really it's not that scary. It's just you need to be careful when you're having a fraction that what you're doing is you actually increase your denominator by a factor of 2. And if you're okay with that, then it is basically the same from here on. It's just, a little bit of fraction stuff we need to deal with. Okay, so we are going to complete the square now. Inside our square brackets, because why not? So this is going to be x. Because this is minus here, this has to be minus. And then this is going to be 5/6. And this we're going to want to expand. So 5 squared is 25, 6 squared is 36, and the minus in front means it's minus 25 over 36, and then plus 7. So now I'm going to need to distribute my negative 3 across my completed square and this term over here. So just distributing that across the completed square just makes that the coefficient. So negative 3 x minus 5/6 squared. Now negative times negative is going to make this plus. And I'm just going to actually simplify my fraction in one step. I know that 3, if I'm multiplying 3, that's essentially going to put a 3 in the numerator. And 3 is going to reduce with the 36. And so when I multiply 36ths by 3, I get 12ths. And it's still 25 up top. Now, in one step, I'm going to do this as well. If I'm going to add my 7 to this, then I need to turn my 7 into 12ths so that I can add it. And 7 times 12 is 84. Okay, so then there's our final function. Our function is h of x equals negative 3 of x minus 5/6 squared plus, so that's going to be 9, 109 twelfths. And a quick sketch, because why not? We're here anyway. So negative 5/6 means positive 5/6, so like really close to the x-axis. At 5/6 is going to be my x-intercept. And 109 over 12 is about 9-ish. So this is 109 over 12. And so our vertex is right close to the y-axis there, with a negative 3, meaning it opens down fairly quickly. There you have it. That is completing the square. One of the easiest ways to go from standard form to vertex form.